Alright, so today we'll mostly just be covering how to open a file and then, making some basic driver code. It won't be anything too complex, but I'm definitely not going to do what I did like last semester and get into the whole nitty gritty before we even get to where that part matters. So if you do have VexCode open, you want to go ahead, click on File, because this is going to be the home page. And remember, the other thing is, I did mention it, but um, unless you're using something that like a new product that just came out, 90% of the time you don't need to update VexCode. Sometimes you will, but firmware updates and everything will still work even if you have an outdated version of VexCode. So don't worry about that. And from here, I believe it was open examples, yeah. So click File, click Open Examples, and then you want to scroll down till you find Competition Template. It's going to be under Clawbot Competition Template. That's the other long one. And you want to make sure it says with no devices configured. So you want to click on that, click Next, and then just name it something. So I'm just going to go ahead and name it Lessons File. So I'll just be using this one most of the time. And then after that, just go ahead, click Create, and you're going to see this screen here. Now, I'll just read through the comments and I'll tell you which ones really matter and don't. So this top part right here, which is kind of like the credits type thing, you want to keep that, but later when you start putting in your own stuff, you want to go ahead and update it. So make like author, your name, created, you just leave alone. And then description, if you want to make it a little bit more descriptive, you can. So I'm just going to go ahead and say main file for robotics lessons. And just get these to line up so it looks nice. Now, so how this works is like, if we use the default settings, any devices that we configure, such as sensors and motors and everything, they're going to end up showing up here. But the thing is, we're going to be manually doing that. We're not really going to be using, hold on, there. We're not going to be using their automatic thing, so you can go ahead and delete that. And then it's always nice to keep your include files up here. And then if you're using a namespace, a namespace is kind of just like, so how do I describe it? It's kind of like, so you have like commands and stuff that you can do, and like very broad, and the namespace kind of like defines each one. And especially like if you have print or read or something, you can have multiple of the same name if you have a namespace. I mean, sometimes this can become confusing because of that, but most of the time, at least for us, you're gonna always want to put using namespace vex, because otherwise, let's go ahead and scroll down here. So here you could, because we have, how the default way to do it would be like, let's say we wanted to sleep for a few milliseconds. So you would do vex, :sleep, and then you would pass in 500. And I believe I have to put in milliseconds after that as well. Oh, why is sleep not working? No member sleep, maybe it was wait. Yeah. But just to make it simpler, so you don't have to put the whole vex :semicolon, because we have namespace vex up there, we can just go ahead and straight put wait 500 milliseconds. So it just helps make your code a little bit nicer. But again, it's also up to personal preference if you want to do it or not. Global instance of competition. This is basically, it's an object technically, but before we get into all of that, it's basically just your definition of competition. So this is kind of like one of the most important things that makes this a competition file. For now, we're going to leave that, but we are going to get rid of that soon, because we're just going to move it. We're not going to completely get rid of it. We're just going to move it. Now we're going to get down to this part right here, and this part right here is called pre-auton. So when your code boots up, like when you start running your code, as soon as you press like play or start, this right here is going to be the very first thing to run, regardless of if you're in a competition or not. This is going to run first. And so that's why in the description does mention that if you want to do anything before some like a competition round starts, like if you want to set your encoders to certain values instead of 0, or you want to reset encoders, or turn on something, turn off something, this is probably the place you want to do it at. Now you're not always going to do it here, but this is a good place to do it. But because, in my opinion, pre-auton is pretty self-explanatory, we're going to go ahead and get rid of this gigantic text block right here. And this is just going to start making this file smaller and a little bit neater. Another thing you can do is, because we talked about how we're going to be putting motors and other devices somewhere else, you can go ahead and get rid of this line right above it. And then if you want, you can go ahead and get rid of these 2 lines right here, which is basically what I described, which was setting just anything you want to do before your main code runs. And then another thing is later on when we have a lot more complex code, it's going to be hard to read sometimes. So if you look right next to the number, if you hover right next to the void, it's going to be a little minus sign. So if you click on that, it'll just hide all the code, it'll compress it. So now this next block that we're going to cover real quick is autonomous. So this is basically every round, the first 15 seconds is autonomous unless you're doing skills, which in that case it's 1 minute. So we're gonna later cover how to make like a little switch button program type thing where you can, or menu program where you can choose what auton you want to run. So that way you can have multiple routines in one program. But for now, we're not going to really get into auton, but we can go ahead and get rid of this massive text block as well. And I'm going to go ahead and leave 3 spaces in there just so it's a little bit more organized. You can get rid of this internal part here as well. And then you can just go ahead and, if it lets me, okay, maybe it won't because it's empty. Okay, and then this is going to be one of the most important parts, user control. So in this one, this is where all of your code for driver control is going to go. So for 1 minute skills / the 1 minute 45 second round, all the code that goes from like your joystick to your robot, macros, all of that stuff's mostly going to be here. Now you might not think this can get complex, but the thing is, generally you want this main file to be as small as possible. So this can be super complex, it just might not look like it, but we're not going to get into anything too complex quite yet. But for now, you can go ahead and get rid of this big text block. We're going to go ahead later and come back and put like adequate comments on these. But for now, you can just go ahead and get rid of it. Same thing with the inside if you want to go ahead and clean that up. Get rid of most of the comments. And then you can move that up. And remember, if you guys have any questions, go ahead and unmute because there's no raise hand or anything. So I'll be able to see if you just unmute. And then this is in main. So this is the thing. So even though these are functions and I said this one runs first, technically nothing in this entire program will run in a sense except for this. So this entire thing you don't want to mess with unless you know exactly what you're doing. But this thing runs all of your code. So this is going to be telling this when to run. As you can see, it's called right here. Then it's going to be telling this when to run, this one to run. Now obviously there's some like deeper hidden code that we can't touch that tells these exactly when to run. Like if you're connected to a competition switch, then don't run. But if you aren't, then run, like stuff like that. But this is like the main thing. So I would say don't mess with this unless you know exactly what you're doing. For our auton switch menu, depending on what we end up doing, we might mess a little bit with this, but I don't think we will. But otherwise, you can still go ahead and get rid of this short text block on top, and we should be done with this main page. So it should be pretty clean, about 50-ish lines or so. Now, if you left comments in or something, then that's perfectly fine. That doesn't matter. So now what we're going to do is we're going to head up to the top over here, click lesson files, and you want to go ahead and click, you can add a description if you want, so I'll do that as well. So let's call this project for robotics lessons. And you just click away, like you don't have to press anything, you just click away or you click somewhere else, it'll save. And then you want to go ahead and enable this first button right here, enable expert robot configuration. And that should already enable expert autocomplete. And if you notice up here, you're going to see this little button that looks like a Ethernet connection. It's going to become grayed out once you enable this. So basically, how they defaulted the program is you add your devices through here. But the thing is, this only works so well, especially for drivetrain. Like let's say in a future game, you have like a 6-motor drivetrain, or for some reason you have like an 8-motor drivetrain. You can't really do that. You can't really add those motors adequately from here. And then, yeah, so it's just stuff like that. It's not horrible, the menu, but definitely not super clean. So what I would recommend is go ahead and close that. Go ahead, just enable expert robot configuration. And I'll put the API into the coding thread a little bit later. But if you ever forget, or you're trying to figure out how to code something, you can always click on help, and you can click on these drop downs, and it has like just a bunch of different commands and stuff that you can do. But if you want more in depth and more stuff to do, or like more actions, you just go to the API and you go to like, okay, I want my motor to do something. So like you go to the class list and then you just click on motors, and then it shows you all the possible motor commands there. So it becomes really helpful, especially when you want to do something but you don't know how to. But yeah, after you enable that, we're going to head over to robotconfig.cpp. So your CPP files are going to be like your main files. That's where the majority of your code is going to go. And these header files are just kind of like, you can think of it as accessor files. So this main.cpp is accessing these files over here. So it's getting information from here. And these files are kind of like the intermediary between main.cpp and the other .cpp files. And I'm calling them .cpp, but any file that ends with .cpp is called a source file. And any file that ends with .h is called a header file. So header files are like intermediaries between the main source file and all the other source files. Now, so we're going to head over here. And what you can go ahead and do is, it says use to initialize code / devices. That's talking about VexCode int right here, init. We're not going to worry about this quite yet. So we can go ahead and get rid of this for now, this comment, but we will come back to this in the future. And then you're going to see here, it says we have a global instance of brain used for printing to the v5 brain screen. Well, I don't exactly like this definition because, I mean, you're declaring devices. The brain is a device. Without the brain, you can't do anything else. So it's definitely used for more than just printing to the brain screen. But yes, you're going to need this. And what we're going to do is we're going to go ahead here. And let me see if I can pull up the API real quick. Let's see. Here. So this is what the API looks like, this page. And this is kind of just like an explanation of how to course through it. But basically, you just want to go up here and you click classes. Just click classes. And you can see this menu right here. And let's go back here. So we have a brain. All right. Now, we want to be able to actually do stuff with the robot. So we want a motor, let's say. So you can come down to, this is in alphabetical order. So we can just come down to motor. Now, you don't want to be using motor 2.9 unless you want to, but motor 2.9 is the old Vex Cortex system, And I believe you guys, especially the newer teams, will not be using this. I think we have enough V5 equipment that everyone will use it. So we just go ahead and click on motor because it is for V5. And this right here tells you, okay, this creates a new motor object on the port specified. So that's what we want to do. If we go ahead and click more, it'll bring us to this screen and it'll tell us exactly how to initialize a motor. Now, if you see here, it says vex semicolon semicolon motor. Well, remember, because we're using a namespace of vex, we don't need that. So we can just focus on this part. Now, if we go back here, how you can do this, how you can set this up is you're just going to go ahead and say motor. So that's the object. And let's go ahead and call it left front motor. So there's a few ways to do that. You can have everything in undercase. So left, enable to underscore front motor. And then you're going to press equal sign. And that's going to be equal to a motor. And then we have to specify what port it's on. So if you look at this first one right here where it says integer 32 index, that's basically asking, okay, I want a port number. So you're going to give it some parentheses. And I believe it was just in all caps, yep. Go ahead and you just select a port. So let's go ahead and give it port 10. And in coding, you always want to end, like 99% of the things you code will end with a semicolon. And that's it. We just went ahead and coded our first motor. Now, this file over here does not have access to this motor. So to give it that access, we have to go to the appropriate intermediary header file, which is going to be robotconfig.h. So over here, yeah. You want me to put it in right now? Yeah, I can do that one. Well, I can send it right now. It's not a problem. I have it open. Yeah, no worries. I'll put it in coding so you guys can find it there, and I'll pin it real quick. And it's not pinned, so let me go ahead and pin it. Pin message. Yep. All right. So there's that. But yeah, I mean, while we're on this page, or actually, let me go ahead and finish this, and then we'll come back to that page actually. So we're over here, and again, this is the same comment that we saw in the other files. We can go ahead and delete that. Doesn't really matter. But if you notice here, it has this almost the same. So let me see if I can open them side by side. Side by side, there's a button up here. Now it's grayed out for me, but if you just click on that, you can open it up side by side and adjust it this way. So you're gonna have two different files open. So if you look at robotconfig, the source file, you'll see brain, the class, and then brain, the object. And then if you look at the header file, you'll see the same thing, but with an extern in front of it. So the extern is kind of like the keyword that's telling it, okay, it's an external object. It's not in this file, but you're going to be able to find it in a different file. So one way to think of it, I doubt it's entirely correct, is you can kind of think of it as this is going to be searching all these source files looking for this. Now, this specific line could be in the Vex header file. We could add it here. But the reason we have it in a robot config, like the same exact formatted name, but with just a different type of file, is for organization. So that way, when you have like 20 different devices and then you have like 50 different functions, you know where all of the accessor type line, like the accessor lines are, that we are not searching through one single file looking for it. So that's the reason why we have the same exact name, but different type of file. So now that we've discussed why brain is here and formatted this way, we have to add our motor. So what we're going to do is we're going to go down a line or two, and we can add a comment. We can just say, we can go ahead and say motor declaration or something like that, or declarations. You can say anything you want. You can also just put nothing. It honestly doesn't matter because, I mean, you should put something, but for something like this, I think is pretty self-explanatory, as in like the name and all that. So now what you want to do is you just go ahead and do the same extern format. So just extern, and then what type of object is it? It's a brain, or yeah, what class is it? It's a motor. Wow, all right. Yeah, it's a motor. And then what's its name? Its name is left underscore front underscore motor. And then you go ahead and put a semicolon. You're not going to get an error, but it's not going to make too much sense. But what we can go ahead and do is just hit compile or build, which is up here. And if you look down here, it's going to go ahead and say build complete. I'm just going to go ahead and clear this output. So trash can icon right there. Because sometimes you're going to be compiling so many times that you're going to have like a couple hundred lines here, and then now you don't know, okay, the compilation I'm looking at, is that from the last time or 2 times ago? Or yeah. So sometimes it's like when you see the message you want to see, just go ahead and clear it. So now we have this defined. Now let's go ahead and define another motor. So let's say motor, let's say right front. Now let's say we want to write it in a shorter way. We can write it as RF motor, or we can start with lowercase if we want. We can do R, and then to separate each, we can do capital F, capital M motor. So there's many ways to format it of a variable. Just remember it can't start with a number, so you can't do like one something, and it can't really start with special characters, so you can't have like say an asterisk something or $sign something. Now, if you manage to find a special character that works, you're probably doing something else, because C++ has it's very character sensitive, and it has certain things with characters. So just remember, don't start it with a special character or with a number, but you can add that. I don't think you can add a special character except for underscore. Let's see. Yeah, you can't do that, but you can add numbers. So you can do like motor, or here, let's say like motor in port 1. I'm not sure why it's giving an error. Maybe it doesn't like the number there. Oh, I think I know why. Hold on. So whatever you decide to name it, you go ahead. I'm just gonna go ahead and say right front motor, but you can call it whatever. I was just talking about variables in general. Let's say motor. Let's call that in port 11. I want to see. Yeah. Okay. So yeah, I was right. You can put a number. Just want to make sure, and I'm not sure why there's a double semicolon, but there you go. And then you do the exact same thing. So go ahead and extern that, type in motor, and then right front motor, and then compile. And this was the one thing I had just remembered. So if we head back over here, if you scroll down a little bit, you'll see right here it says bool reverse or gear setting gears, or gear setting gears and bool reversed. So most of the time you're not going to worry too much about gear setting gears, because this has to mostly do with, I believe it's the gear cartridge. So how the new motors work is they have like 3 separate gear cartridges that you can swap. So you can have normal, which is considered green. So if you like look at a motor, it'll have like a green line. If it's red, that means it's geared for torque. So it'll spin slower, but it'll spin with more force in a sense. And the other one is blue, which is for speed. So it'll spin faster, but it won't spin with as much force. But most of the time, even if you switch the gear cartridges, you're not really going to be too worried about gear settings. But bool reverse is a big deal because of the fact that if we come back over here, let's say all motors, because all motors are this, they spin. I think it was, I want to say it was clockwise by default. So, but the thing is, if we have a motor facing the left and a motor facing to the right, one of the motors aren't going to be spinning in the same direction because their clockwise is going to be different from each other. But the thing is, when you're coding, you don't want to be like, okay, motor to go straight, motor one spin positive and motor left spin negative, because that's counterintuitive and it becomes super confusing. So you want to make one of these spin the opposite direction of the input. So if the input's 100, instead of spinning forward at 100%, spin backward at 100%. That way, the motors are spinning the same direction, so your robot goes forward rather than spin in place. So you can do that to whichever one, left or right. I typically do to the right. So if you look back at here, it says all you need is a comma and then the boolean. A boolean is just true or false. That's what a boolean is. It's a data type. So that's not it. Here we are. So we're gonna come here and for the right, I'm gonna put comma and then just true. And all this does is it reverses the right motor. Now, if you want to, you can go ahead and put false, but by default, it's set to false, so you don't have to do this. Now, what you want to do is, I'm just going to go ahead and get rid of this false, just to make it a little bit more simpler. And let's go ahead and I'm just going to go ahead and add the other two motors, so left back and right back as well. So left back motor equals to motor port. I know port 20 exists. We'll do that. And then motor right back motor is equal to motor. I know 21 exists. I think there's only 21, if I'm correct, which I'm pretty sure I am. Yeah, there's only 21 ports on the brain for their Ethernet type cables. Now, for 3-pin cables, they do have, I think it was, let me check. They have, what is that, 8? They have 8 3-pins, and you can expand that, but we're not worried about that right now. Let me go ahead and reverse this real quick. And then just come over here and remember to make the accessors so that, the other file can read it. Other thing you can do is when you start typing, you'll see like, because we have expert autocomplete, because we're all hackers here. If you start typing something, there's a high chance it's gonna come and highlight it here. So you can just scroll down, press tab, and be done with it. And then I'll go ahead and move this comment over here as well. Now, if you notice something, these are all objects, even the brain, and they have like, their name and their class name and their specific name. If we come back over here, we have the same thing with the competition object, this global instance of competition. So what we can actually do is we can go ahead and clean this up more by moving this to the source file. So delete, and you're probably going to get a few errors over here. Let me see. Yep. The reasoning? Okay. So if you look here, these are all objects. So you have a class. So here the class is a brain. So that means whenever you are coding this with this name, you're gonna have specific commands to this variables. You can think about an object as a variable with more than one piece of data. So when you have, let's say, an integer, right? You have an integer, let's call it hi. This integer can only hold integer data types, and you can only do certain actions with that based off of this integer type class. Now, I'm pretty sure integer is not a class, but kind of like for the idea. Now, the same thing applies here. So brain is the class. This brain is just the name of like a big variable, you can think about it. But because it's a class, this variable can hold a lot more data. So it can hold like a string data type. It can hold like 5 or 10 or 100 different integer datas. And all of that data is unique to this. Now it can be identical across multiple objects, but it's going to be unique to this because of its name. So you can even have like another brain. I don't think it'll work, but in some instances you can do this. Yeah, so you won't work because now the computer is going to be like, hold on, you already have one object slash variable named brain that has unique characteristics to it. Why are you doing the exact same thing again? Like that doesn't work. So because we have all of that here, we have these classes with their objects. We have that same thing with competition. So even though it doesn't seem like it, this capital C competition is an object of the class competition. So that means this is essentially a variable that's holding a bunch of information relevant to only the competition class. So to clean up our code and put all of our main, in a sense, devices and objects in one spot, we can go ahead and move it to this file. That way it's not here. Now what's going to happen is if you come down here, you'll see that this competition object up here is being used. So if we go ahead and copy this and we delete it, you're gonna see like you have errors here because it's gonna be like, oh my god, you're using something. It says use of undeclared identifier competition. It's like, hold on, you're saying you have a competition object, but that doesn't exist anywhere. So you gotta fix that. Well, yeah, we're gonna fix it. What we're gonna do is we're just gonna go to Robotconfig and at the top probably. So you can go ahead and paste it in. Now this doesn't fix any of the problems. You're gonna see down here, still undeclared identifier. But what we're going to do is we're going to come over here to our header file, which is our accessor type file. We're going to go ahead and do the same thing. So extern competition, because this is the class. And then what's the name? It's competition, but with a capital C. And then semicolon. We still have the error. So unlike other like development applications like Visual Studio and Visual Studio Code, VexCode doesn't like instantly update. So even though this code works, we're probably going to have this error on compilation. So let's go ahead and compile. Now if we come here to output, we see that it says build complete. But if build's complete, why do we still have two errors? Well, that's going back to what I said where VexCode doesn't always do it. So sometimes just clicking on it like that fixes it. Other times you can go ahead and delete one character, add another character, and then it fixes itself. And as you can see, we have no more problems because you have competition declared here. Your header file is accessing it through this line. It's telling it, okay, this definition exists external somewhere. Look for it. Okay, it found it here. So now we know that this exists. And in this main file which is accessing this file is like, okay, I want to use that object here. Does it exist? Well, in this file it exists. This file says it exists in this file. Okay, so it exists, we're fine. Now, if that kind of tracing was confusing, I'm sorry, but in the future, not in the near future, but definitely in the future, it will get a little bit more confusing because we're going to start making our own custom ones, our own custom source and header files. But if you can kind of think of it like that tracing route, like from here to here to here, or from here to here to here, just in reverse, you'll eventually get it. It's a little confusing at first, which is understandable. So now we actually forgot something. We forgot a controller because you can't just, for driver control, which is typically the easiest to code, you can't exactly drive without a controller. So let's go ahead and add a controller. I'm just going to say definition this time. Now in Vex, this is just kind of like a little information. You can use multiple controllers. I think 2 is the legal competition max. Now, no matter how complex your robot is or how complex the game is, I personally would not recommend ever using 2 controllers because if you're using one controller, yes, you're going to need practice, but let's say you need 2 hours of practice to understand all the controls. If you have 2 controllers, not only does each driver have to understand how to drive, and what the controls are, but they each also have to be able to work together perfectly. So that's going to require a lot more work. And even though it doesn't seem like a big deal, finding practice time is hard to do, especially if you're kind of just going into it. Especially if you're coder. Coders typically don't get the most practice time. So besides that, let's go ahead and we're gonna pretty much be using this. Eventually we're not gonna be using this as often, but just for now, so you kind of get the hang of how to use it. We're gonna go ahead and look for controller because that's what we need next. So we come down here. There's our competition class that we were looking for earlier that we just used, but that doesn't matter. But here's controller right here. So we go ahead and click on that. And then it says, okay, so controller has subclasses, but we're not really concerned with that. And then we see creates a new controller object. So this is what we want. Now this controller type ID part, this has to do with if you're using like 2 or 3 controllers together for one robot, but as of now, we're not concerned about that. If someone's curious about it, I can cover it, I'll say later. I don't want to do it that today, but we're going to be using controller. So click more, and it tells you, okay, just do it this way. Vex, double semicolon, controller, double semicolon, controller, and then empty parentheses, nothing inside. Well, ours is going to look a little bit different because we're using namespace Vex, but it's still going to follow the same format as this other general stuff. So we're going to go ahead and type in controller, because that's our class. Let's give it a name. I typically like to go by, I either typically say controller or master, because it's your master controller, it's the main one. Then equals a new controller object, and you can just go ahead and click on the second option because we don't really have parameters for it. Now I believe you might be also just be able to do it like this. Yeah, so you can also do it like this. Because it's just a controller, it doesn't really have parameters, but if you want to make it super, like, not official, but I'm not sure, can't think of the word right now, but if you want to make it a little bit more standard, I guess you could do this, but you don't have to. Just do it like that, and we're going to go ahead and come over here and add that in. So what I'm going to do is I'm just going to go ahead and copy this entire thing, come over here, and then just add extern in the front. And now we can finally start. Well, okay, hold on. Before we start coding everything, let's go ahead and compile. So compile. And you want to do this regularly so that way you're not coding a massive block and then you press compile, something breaks, but now you don't know what caused it to break because you wrote so much at once. So compiling regularly is a good thing. And working in little chunks is also a good thing. So now let's go ahead and start doing some basic driver control. So this code is pretty much standard across the board for getting a robot to drive around. Now, there are things you can do with like motor speed and like getting it to drive straight only if a button's being pressed, but that's a little less standard. But almost all the time you're gonna have something similar to this. So you're gonna come to the while loop, and a while loop is basically how it works is it's kind of a logic statement. So while the statement inside is true, inside these parentheses, you're going to keep running this, in theory, infinitely fast for as long as this is true. So you can exit a while loop as long as something on the inside sets the parenthesis up here to false. But in user control or driver control, you don't want it to turn off, you want it to keep going. So you can either set this to true, or because I think everyone knows, okay, I'll explain it. In coding, everything's just zeros and ones essentially. So how 1 is on / true, true is equal to 1, therefore you can just put 1 in here. Now, another thing you can do, which is kind of broken, is you can put a big number in here. Because how these logic statements work is, as long as it's not 0, it'll count as true. If it's 0, it counts it as false. But typically you should either put 1 or true. I like true better than 1, so I'm going to put true in there. And now for driver control, you don't really need a logic statement. So what you're going to do is you're going to go ahead and type in, well, let's see, we have, let's start with the left motor. So left underscore front underscore motor. We're going to say dot, because dot means, okay, we're going to do a command unique to motors. All these motors have this command. So you see we have current percent units, direction, efficiency, installed, is spinning. So some of these are Boolean, which means it'll return like true or false to you. So it'll say, if you run it, it'll be like, okay, this motor's turning. Okay, this motor's turning. But we want this to spin. So luckily for us, it's pretty easy. You just say spin. And you can see there's 4 different types of spin at least. And there's a bunch of different types of spin 4s. Now, I think this is the one we want to use. Let me just double check by reading it. Yeah, so this is the one we want to use. So I just clicked on it, and you can see we have errors, but that's because we haven't put in any information. So we're going to start putting that in. So direction type, you're going to go ahead and delete dir. You're going to add 2 semicolons, and then you're going to get this option. So forward, reverse, or undefined. Now, undefined makes little sense most of the time. I personally have yet to use undefined, but you know, we want it to be, if you go forward with the joystick, you go forward. So, and yeah, you have a question, Daniel? Yeah. Okay, so let me see if I can. Yes, there's a dot between motor and spin. Yeah, try that. If not, you could also screen share if you can, if you're able to, and I could help you out. Yeah, there's a double colon right here. So in C++, it's kind of like a unique thing to, well, C and C++, because C is like the parent language, but it's kind of like how do I explain it? It's like it. Well, I'll find you an official definition. I won't make it up. Let me see if I can get one. Yeah. Why do you use? So it's called a scope resolution operator, and it basically, it says it gives you more freedom in naming your variables. Okay, so it's basically you can have variables of the same name, but the double colon lets you deal with that and make it unique in a sense. So, I mean, that doesn't make too much sense, but how you can think about it is forward is a variable or is like a thing that exists for all the motors. But this double semicolon is saying unique to this motor, the direction is going to be this. Yeah, I'll probably find a better definition for next week, but that's, yeah, yeah. So, yeah, so if you got this part to work so far, that's fine. You're going to have these 2 errors. And double velocity, double is just a variable type. I believe it's 16-bit or 8-bit, one of the 2, which basically means you can have a pretty long decimal, one of the longer decimal options. But the thing is, we don't want to give it a set speed, we want to give it a speed based off the joystick. So what we're going to do is we're going to say, what was our controller name? It was master, so I can't spell master, dot. Now you get this drop down after you press dot. So dot's like I want to run a command off of this object. Well, okay, these are the different things you can run. Well, on a joystick, let me see if I can find a quick picture of a Vex joystick. Vex V5 joystick. A controller, I should have said. This is a good picture. So as you can see here, they have like these axes defined. So if you go up and down on this left side, it's defined as axis 3. Go left and right, that's going to be axis 4. So that's what it means when it on this drop down, it tells you axis 1, axis 2, axis 3, or button 1, button 2, because all of that's defined here. So this is going to be like button left, button right, button Y, button A. Then you have I think this is like I forgot what that one was exactly. Oh yeah, L1, L2, stuff like that. So we're concerned, let's say we want the left joystick to go up and down for the left side of the drive. So that's going to be axis 3. And come back here, left motor, so we can go ahead and do dot axis 3. Well, okay, axis 3, but that's not really giving us a value. That's just saying we're doing something with axis 3. So then you press dot again, and you have these 3 different options. Changed is going to basically be like, okay, if the value changes, call a different function. We don't want that. You can get position, but you can get value. I prefer value. Position is just a little bit different. Not too much though. So you get value, press tab. Don't add it with 2 parentheses, which is fine. And then you come to percent units, and we're going to do the same thing we did over here with direction types. You're going to go ahead, delete units, add 2 colons after percent units. And it's only going to give you the option to do percentage. But if you did something like, let's say, velocity units, or velocity units is a better example. If you had like velocity units, which is easy to do, you just you delete percent, add velocity. This is still legal, but it allows you to do stuff like RPMs or DPS. But percent's always good because 100% at the top, 0 at stationary, and negative 100% at the bottom. And what this right here does is this right here controls your left front motor off of the axis 3 value. So if your axis 3, let me see if I can split screen this real quick. Ooh, I can go ahead and close that. So can I? So if your axis 3, which is this one right here, up and down, if it's stationary, which means you're not touching it, it's just in this default position, that means you're inputting a value of 0 into the motor, so the motor's not going to spin. If you jack this all the way up, you're inputting a value of 100. Well, what type of value is that? That's a percentage value. So that means it's going to spin the motor forward at 100%. And if you bring it back, if you bring it all the way down, well, now you're plugging in negative 100. Well, what type of value is it? It's percent. So the motor is going to spin backwards in negative 100%. Now, instead of forward, if we put REV, which is reverse, it would be the opposite. So if you jacked it all the way up, it would move backwards, and if you put it all the way down, it would move forwards. But that's counterintuitive, and you don't typically want that. So you're going to go ahead and put forward. Now you're going to follow this same format for everything. So I'm going to go ahead and copy this real quick because this applies to the other left motor as well, so you might as well add that. So the other motor is going to be left back motor. Did I name it something else? Oh, I named them all front. Okay. Let me go ahead and fix that. So that's another thing. When you're actually defining it, like over here, you're going to get an error if it has the same name. But in these accessor files, you're not going to get an error. So you always want to make sure that the name works out. So even though there's an error, because I know I fixed the problem, I'm not going to worry about this for now. You can copy paste that, and it's going to do the same thing for that left side. Now we can go ahead and copy both these lines, come down here, and change left to right. And here's the little caveat. So typically, because the right motor has a different clockwise than the left, you would put reverse here so that forward is still, forward, and backward is still backward. But because we put the reverse part right here, we're setting, backwards to actually be forwards, we can leave this as forward because the reverse was done over here. If we didn't do the reverse over here, you would do it over here, which adds confusion, hence why we do the reverse here. And by the reverse, I mean direction, reversing the motor direction. And this is the right motor, so we don't want it to be running off the right or the left joystick. We want it to be running off the right joystick. So that says axis 2 right there. 2 is the up and down arrow. So you can just come over here to 3 and make it a 2. And then it should compile. Build complete, 2 problems. Well, not anymore. And just like that, we now have code that allows us to drive a robot with 4 motors, 2 on the left, 2 on the right, to go forward and back using the 2 joysticks in the vertical directions. Now, we are going to be wrapping up today, but if you want to go ahead and try it, one little, not assignment, because I can't force you to do any of this stuff, one little thing you could try doing the challenge, it should, assuming that you kind of have an idea, you could either write this down, like the logic for it, but basically try to see if you can figure out the logic or the code to get it to work that if I press button A, the entire robot goes forward at 50% speed. Otherwise, it checks this code. Now that sounds kind of complicated, so that's what I'm saying. If you don't know those type of logic statements yet, don't worry about it. But you could still try writing out the logic behind it. Be like, okay, if I do this, this happens. If I do that, that happens. And remember, it's a computer, so if you don't tell it to do something else, it's not going to do something else. It'll do exactly what you wrote. But yeah, other than that, we're done. So I'm going to go ahead and stop this.